All right, so this is where we left off on Tuesday. Okay. So we are coming to the last part, which is on string operations. So string operations, essentially, you have these two first. Inclusive. Inclusive, that means, let's say you have a string that is within a string. So let's say you have a string. If there's a certain component inside the string that is in that means it's inclusive. Exclusive is just not within. Okay. So you know that in maths, addition, let's say we have, for example, addition is, let's say 2 plus 2, it will give you 4 in maths. Okay. But when you have, let's say, AA plus BB, it actually gives you AA and BB. Okay. So when you add strings, remember strings is just any characters. It can be words, can be anything. It becomes a concatenation. When you multiply, it becomes a repeat. So it means that when you have, let's say, AA, you multiply by 3. So it becomes your AA, AA, AA. Okay. So it's 3 times. Subscript is when you take a part of a string. Okay, so let me just show you how it looks like on the next page. So here we have this string. Is ATG within this string? Okay, so you actually, Python will try to find is ATG within it. So ATG is within it. So ATG in this string, so it gives you true. But in here, ATG is still within it. So ATG is still in there. And you actually ask if ATG is not in this string, but since it's in, it gives you false. So this is what concatenation does. You just add up the two strings together. Okay. So this is where the two strings are. This section, and then this, no, the GC part, this part. Okay. So let me just remove this little squiggly. Oops. So you end up with, here is the division line that comes from this. Okay. So concatenation is just adding up. Now, when you multiply strings, let's say ATG times 3, you get 3 of them. So you end up with 3 of ATG. Okay. So that is concatenation. We always use concatenation for different purposes. So let's just use this example. Subscript, let's use the example here and see what happens. So I change my words, numbers into string. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if I do a subscript 0, do a subscript, let's say 3. Okay. So basically, in mathematical terms, this is what it means. Okay. If let's say your, okay, see, let's say your x equals to 1, 2, 3, 4, 5, 6. Okay. And then I say x subscript 2. What do you think it will give me? In reply, x subscript 2. I'm sure you learned about subscripts before. You know that when I teach you on your statistics, your average, it can be written as the summation of all the x subscript of I divided by n. So this is what subscript means. So subscript of 2 gives you what? Anyone alive? You can type inside your chat, the meeting chat. What is the answer? Everything. No, it's not multiplication. So subscript of 2 is not equals to 2 times x times 2. Okay, you do not know what is subscript. Okay, so essentially you can look at it this way. Let me just clean off this whole chunk. too many stuff. So let's say let me just produce another slide, new slide. Okay. So for example, you can have something like this. Okay. So let's say you have X that is just alphabets. Okay. A, B, C, D, and E. So you refer to, let's say you have X subscript 1 is actually equals to, that means you actually is equals to A. That's what subscript means. Okay. So why is this important? Let's say when you do okay, this is a very important concept. For example, you have your data. Okay. Data will consist of different numbers. Let's say 1, 3, 5, 7, 9. And I ask you to find the average of data. You know that average, the formula is the summation of X subscript I from I equals to 0 or I equals to 1 to n. Then you divide the whole thing by n. So what does it mean? Here you have summation of data subscript of I divide by n. The same thing. So you expand it out will be data subscript of 1 plus data subscript of 2 all the way to data, the last subscript of n, divide by n. So what it means is you have data subscript of 1 is 1 plus 3 plus 5 plus 7 plus 9. Then you divide the whole thing by 1, 2, 3, 4, 5, which gives you 5. So do you get an idea of what subscripting is? Otherwise, how on earth you understand this formula? Anyone still confused? Yes, no? Okay, question is, do you actually know, can you actually read this formula first? Mathematically, do you understand what it means? Okay, you understand it? The rest? Okay, so let's come to another part. So let's say, if I give you X, okay, is a list of numbers. So 100, 101, 103, 106, 108, 200. Okay. So if I ask you what is X subscript 1, what will be the answer? Yeah, it's 100, correct? Okay. So automatically X subscript of 2 gives you 101. Yeah. So you get it now. Okay. However, we want to see in Python how does it work. So now, if I have this 1, 2, 3, 4, 5, 6, 7, 8, 9, because each one is a character now, I do a subscript of 3. What do you think it will give me? 3. Okay, try it out yourself and see what happens. Give you 4. So it gives you 4. Now, how do I get 1? What subscript do I have to use so that the answer is 1? 0, correct. Okay. 0. So this is where Python and maths is slightly different. Okay. This is the part whereby you know it regularly from your maths. But Python in this case, it is using a 0 index. Okay, what you call is a 0 index. Okay, that means x to the 1 is actually equivalent to, in maths you write x to the subscript of 2 because it starts with 0. Okay, or you just write x to the power of 2 minus 1. Okay, because you realize that we cannot type subscript and superscript here, we have to use bracket. Okay. So x to the power to the subscript of 0 or x to index of 0 is equivalent to, in maths terms, 0 or 1 minus 1. Okay, 1 minus 0. Okay, so we get this part first. Okay, now sometimes and very often we realize that we want the last number. So let's say, how do I get to the last number? If I want to print out 9, what should I use? If I want my answer to be 9. Yes, can you minus 1? As you can do that. You can do 8. Oops, you can do 8. Oh, what did I do? Okay, do 8. Give you 9. Or you can do the reverse index. So minus 1. Minus 1 is the last one. Okay. So automatically, I want to get 8. I can say that it is minus 2. So I can do the reverse. Okay. So what happened is, that's not what you see here. So if I give a subscript of 9, technically it doesn't give me anything. Correct? It tells me that the list is out of range. Okay, it doesn't give me anything. It will give you an error. Now, this is a very important part about Python. Some programming language doesn't give you an error. Okay, and if it doesn't give you an error, it means it's trying to read another part of the memory that it's not supposed to read. Okay, and that becomes a serious problem. That's how you write viruses, computer virus. Okay, because you can read and write into another part of memory. Now, since, okay, let's call this as your data first. Okay, so now I can say data subscript of minus 1 will be 9. So Python uses this simple idea that whenever you can read, you can write into it. Make sense? So how do I change 9 into, let's say, another number? Or another alphabet for the matter of fact. So I can say that data subscript 1, origin is 9, right? I want to change it into, let's say, A. I can do that. Okay, string does not list assignment. Okay, so you can't do that for now. Okay. But the main idea is you can actually do a subscript inside. The next part is you can actually take a part of the string as well. So a part of the string means that you can actually do this thing called slicing. Okay. So for example, we go back to our data. Okay. So for example, what I'm doing here is if I take from 1, 2, 3. That means I start from 1 to 3. What do you think the answer will give me? That means I want to do 2, 3, and 4, right? So, but let's see the answer. It's only 2 and 3. That means I'm taking these 2 and 3 and pull it out. But what you expect is 2, 3, and 4, right? Because I'm starting from position number 1. This is position 0. 1 is position 0. 2 is position 1. 3 is position 2. And then 4 is position 3. Okay. So it's important to realize that in this case, oops, mess it up again. In this case, let's say you have a string, and then you have m to n. The m is inclusive, the n is exclusive. So that one is inclusive, one is exclusive. Make sense? Okay, that means if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, I will just put down the, let's say I want from 2 to 5. Because this is inclusive, so I take 2 out. That means I bring out 2. But up to 5. 2, 3, 4, 5. So I up to 5, but this is exclusive. So I go on and just use up to 4. So 2, 3, 4. Because 5 is exclusive. Okay, what is K? K is here, it states that the interval. Okay, because K originally by default is 0. So what do I mean by this? So I can say that, let's say data, I go from, let's say 0 all the way to 5. Okay, so I have this 1, 2, 3, 4, 1, 2, 3, 4, 5, right? But I say that I skip 1. That means it gives me, it skips nothing. So let's say if I want to skip 2, it gives me 1, 3, 5. What you can see is it actually skips. That means it takes 1, take 1, miss 1, take 1, miss 1, and so on. So that's what skipping means. Okay. You can skip multiple. For example, you can skip 3. If you skip 3, becomes what? That means you take 1, the first one, and then you take the third one, and then the third one, and so on. So what will it give you? Okay, you try out 1 and 4. Okay, because it take 1, the first starting number, then it's skip 2. So the third one is 4. After that, it try to get a third one, there's nothing else. Okay, that makes sense, right? So far, so good. Now, what is also interesting is, can you do something like this? 1, 2, okay, let's go back. It's 1, 2, 3, 4, 5. Okay. What happens if I do a reverse? It gives me nothing, huh? Because you cannot jump backwards. Okay. So the skipping doesn't jump backwards. Okay. You got the idea first? That means, let's say, let me just go to this string. So let's say I get a short sequence, and I call this, call it a sequence. So what I can do is I can have my sequence. If I want to have that whole sequence, okay. So let's say I want to go from 0 to 10. Okay. So it gives me 0, 1, 2, 3, 4. So it gives me 10. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it gives me this 9. Correct? Any problems so far? But very often in Python, 0 is understood. So we can also shorthand and remove the 0 here. It will still give me the same thing. So if I do this, I say that 0 to 10, and by default is 1. Okay, by default is 1 because it will give me everything. If I want to skip, that means take every second alphabet, every second nucleotide, I'll just skip this. So far, so good. Okay, at least for string, you roughly should know how to use it in the first place. It may not be that clear, but it can be quite useful. Any problem so far? Yes, no? Can you understand this part? The difference is I can use a number as a string, or I can use a character as a string. It doesn't make a difference. Okay. Now, what you need to do is try out these few examples. See whether can you get it clearer. Okay. So you tried out these examples and see what happened. Try to make sense of it yourself. The only one that you probably will get into a problem is the last one, this one. Okay. This. The rest you should be able to understand. Try to spend the next 5 minutes and play with it yourself and see what happens. Okay. Try to work it out. Change different starting, ending. Change different skips and see whether can you get it or not. Okay, any problem? Anyone has any problem here? Okay, if you have finished a few tries, then you just drop me a message on the meeting chat, say that you have finished, so I can go on. Last one, how? Yeah, just try the last one and actually see what happens. What is it trying to do? Okay, so last one, what it did is it actually do the reverse. Okay, so because it starts from -2 and at 2, so you are essentially taking 2 -2 and ends with 2. So you're taking this, you're reversing the alphabets in the first place. Then only that you can do the reverse. So -5, you can actually do the reverse because -2 to 2 is already reversed in the first place. Okay, we seldom try to use this because it can be very confusing. Yeah, you can do this. It will give you the answer, no problem. -2 to 2 minus 5. You just do the reverse. Okay, because the first step is you have to know what does -2 to 2 gives you. It gives you nothing. But because of that, you can actually do, because you are actually reverse skipping. Otherwise, forward skipping, it doesn't make any sense. Let's say, for example, you take -1. You see this part is essentially the reverse of itself. Okay. So you just take this until you hit the C. Yeah. So here, you take this portion, you reverse it totally, alphabetically reverse. So G, T, A, and so on. You read from the opposite direction. And because of that, you can actually do a opposite -5. Because you can do a -1 first. Okay. Seldom you'll want to do something like this. Okay. Of course, the only time that I can see you doing something like this is when you try to calculate or compute the opposite strand of something. So I can actually do this. I can say that. Let's say what can you do? What have I done essentially here? Any idea what have I done here? Yeah, technically I reverse the whole thing. Yeah, I flip it. Okay. So once you can do this part, right? Can I actually do flip? But when I flip it, I want alternate only. Okay. So you see, I flip it, I only want the alternate only. So it's C, I skip 1, I take a T, skip 1, I take a G, and so on. So then you can actually understand how does this work. Rather, how does this work? Okay. So you go step by step. Try to simplify things one at a time. So far, any problem? Again, we seldom like to use this as well. Okay, because it can be quite this is a fast way of reversing a word. Okay, it's quite useful when you try to find palindromes or something. For example, you can type in whose name should I use. Let's say I just use my own name. Oops. I can do the reverse of my name and see what happens. Okay. So if you like to write in reverse script, this is how you can do it. It's just not going to be easy to read, but you can read it off a mirror. Okay, so far so good. Let's see. Is there anybody? Activity? Okay, nothing much. Okay, so let's continue. Okay, once we are done with that, the next thing we want to do is this thing called calls. So call is like calling a function. Okay, so let's say in mathematical terms, if I say that fx equals to x plus 4. This is a mathematical function, just a super simple one. And then if I give you f, x, I give you 2. So what will be the answer? Will give you what? If this is the function, 6, because it's actually 2 plus 4 equals 6. Okay, so you actually got a simple thing. This is what we call as function call. This f is your function name. Okay, this is what we call as the parameter. Okay, so let's try something else. We can say that For example, you say that G x plus y, x and let me just get this over, delete. Oh, dump this thing first. Oops. Okay. So we say that we leave it f x is x plus 4. Then we say that g x and y, okay, equals to x plus y. Okay, so if I give you 3 and 2, what will you give me? You put g 3 and 2 into here, what will you give me? 5, correct, because it is 3 plus 2, because it's substitute in, equals to 5. So this you do not have a problem. This is essentially what we call as function calls. Okay, x is a parameter, so these are also parameters, just that now there are two parameters instead of one. Okay, so function g has two parameters instead of one. So let's continue a little bit. Can I take the output of a function to put inside the input? So let's say I do this. G f 3 6. How do you compute this? Okay, so think like a computer. How will you compute this? Okay, so mathematically you just do step by step. Since f this right is actually goes into x, so it will be f 3 plus 6. Okay, then will be you expand f3, so it will be 3 plus 4 plus 6, because this is from this function here. Okay, and you end up with 13. Make sense? Can you understand this whole part? Any problem? Yes, no? You expand out part by part. So this you expand into here, 6 you expand into y, so it gives you here. But fx, f to the f 3, you go inside here, you expand what is f3, so you get this part. Any problem? Yes, no? Yoo-hoo, somebody answer me. You have to realize I'm actually talking to a computer screen, right? I do not know whether you understand or not. Okay, kinda. Okay, so kinda is good enough. Not too bad already. Okay, so since we kind of push it a little bit more. Seriously, this computer screen is not very friendly. Okay, so then let's do this. If I say G, okay, what how will it be? I just do a double, I just expand it twice. So I expand once, this will be 3 plus 4. Okay, then plus, this will come down as, what did I do? 4 plus 4. Okay, so here will be 7 plus 8 equals to 15. Any problem here? So it's really a lot of programming is on maths. So this is really the maths part of it. Anyone confused? If you're confused, then I show you another example. If not confused, then just tell me you're okay. Okay, Joanne is not, is all right. Hazel is fine. Ryan's okay. The rest? Okay. All right. So I think we are getting there already. Um, Before I forget, someone might want to know. Remember on Tuesday I told you about the learning portfolio, right? Okay. So learning portfolio, remember? Okay. So the question is, how many entries do you need? Okay. I would say just give me about 10 entries. Okay, so 10 entries split across the different days or what. It's up to you. So 10 entries is what you need at least. Okay, the more you write, the easier you get marks actually. So go to your study guide and actually there are 4 questions, kind of list down what are you supposed to have. Okay, so let's settle this part ready. I've also put up the individual assignment, so you can take a look. Probably sometime early next week, then you will pick whatever snippet of codes that you want. So just don't duplicate. Okay, I kind of just leave it up to all of you because there's only 15 of you. Go and discuss among yourself who want to do what. The difficulty level for everyone is roughly the same. So some of the codes may look longer, but it's actually not that tough. Some of the codes may look shorter, but it's actually a bit more confusing. Okay, so function calls. Python always have many functions. In fact, every programming language there are functions. Think about functions as the formula inside your Excel. Okay, so functions in Python is actually equivalent to your formula in your Excel. Okay, you find that some of it you already actually know. For example, what is length, what is maximum, minimum, absolute, and so on. Okay. Now, where do you find all the functions in Python? Now, Python have a lot of functions inside this thing called a standard library. This we'll cover, I think, in topic 5. Okay, what the standard library contains and so on. But if you really want to know what functions Python has, you can go to this page. Let me just, can't even move this thing. Okay, so just, okay, my end to move away. Okay, so you go to Python standard library. First time Python standard library, will give you a whole list of documentation. So these are all the functions that is already inbuilt into Python. For example, you have your maths library. Where is my maths? Okay, your maths mathematical functions. Okay. You have a whole list of different things. Okay, for example, your power, logarithm, your cosine, trigonometric functions, your conversions, your hyperbolic functions, and so on and so forth. Okay, so all these are special functions which you seldom use. All right, if you want to print out, I would not suggest, but if you desperately want to print out the whole thing, it means all these functions, right? If, what you call it? If you want to print out the whole library, you can actually print out. It is going to be about 1,200 pages or so in your A4. All right. Okay. So we can use all these functions for different purposes. For example, I already show you some functions. Let's say, for example, around the print. Print, let's say, Irvin's name. Okay. So it prints for me. Print is a function. You realize that function is enclosed by round brackets. Subscript is by square brackets. So this is the point in Python that I want to explain to you, that the three brackets means differently. Round brackets, square brackets, and curly brackets are different. They are not the same. Okay, so round brackets, you can use it for functions, function parameters. There's also actually a second one that you can use it as a tuple, which we'll cover next week. This square bracket, you have it as your index. Index simply means your subscript. Then it's used to define, so this is define, define a tuple. You can use it to define a list. This, we use it to define what is known as a dictionary. Okay, we'll talk about all this next week. Okay, so this week, still don't bother with it first. Okay, so far so good. All right, so we come to functions. So for example, len stands for length. Okay, so you go and read the documentation, returns the length of a character. Okay. You can also go to the Python standard library. You have this thing known as built-in functions. So built-in functions will tell you what it does. So these are built-in functions. You can go and find what is length, and it tells you what the length is. Okay, it returns whatever, and so on. Okay, so all these are Python built-in functions. Okay. So for example, I can take my sequence. For example, do I still have my sequence? I still have my sequence. Okay, I can do a length to actually find out how long my sequence is. I don't have to count. Make sense? So my length of my sequence is 19 nucleotides. I don't have to count one by one. You just do a length, and then it will be quite easy for you to find out. Okay. So I can do a print, I can do an input, and so on. Maximum, minimum, and all the different stuff. So for example, in last week, we have this problem of integer and float. We can actually convert them from one to another. This is what we know as your typecasting. Typecast. Okay. Typecasting means that it changed from, let's say, an integer to a float, or a float to an integer. Okay. Sometimes it could also be changing from a string to a float as well. Okay. So let me show you how does it change from a string to a float. Okay. So for example, if I have 1, 2, 12 plus 3, 3, 4. 1, 2 plus 1, 2. Okay. What do you think? What do you expect it to give me? 24. Yeah, I correctly. If it's 12 plus 12 is 24. But here it gives me 1, 2, 1, 2. The reason is I actually use inverted commas. See, I use inverted commas. So this 1, 2 is actually becoming a string. It's actually becoming a string. So let's say I take A and I say 1, 2. You look at here. See, A is actually a string. It's actually a string. But if I say B equals to 12, now I say B is actually an integer. It's different. So I say B plus B will give me 24. But I say A plus A is a string concatenation. Make sense? Can figure out this part here. This is actually a concatenation, a string concatenation. B plus B is addition because A is defined as a string while B is defined as an integer. So far, any problem here? Yes, no, Ambrose? Anybody have problems? Yes, that means you're okay, right, Ambrose? Okay, fine. Okay, so how I can actually say that, can I actually try to typecast this 12 into a integer, for example? So I can typecast it, use an integer, force A into integer. Okay. But before I go there, what happens if you try to add a number with a word? So I add A plus B. What do you think will give me? Will it give me 1212 or 24? Or give me error? Yes, it give it error because it says that it cannot concatenate a string to an integer. It doesn't know what to do. What it is expecting you to do is, should I be doing this? I change my A into an integer and then change my A into an integer as well. Give me 24. Or should I force my B into a string and B into a string, and that gives you 1212. I'm doing the opposite way. So both are equally correct. It doesn't know whether it's supposed to change. Let's say for this, one is a string, one is an integer. Am I supposed to change a string to an integer or the integer to a string? So it doesn't make a decision for you. Make sense so far? Okay, so for example, I say name, I put my name. You already have it. If I take name times 2, you just multiply because it's concatenation. Is it possible to do it? So when you ask whether is it possible for Rebecca, just try it. Can I take integer A, because A is a string, and then just add it to B? Of course. You can. What is also interesting here is, since my A multiply by 2, it gives me 1212, right? What happens if I take this multiply by 2? What will this give me? One, two, two, four, correct? Because A multiply by 2 is 1224. I convert this 1212 into a string. I plus 24, so it's 1224. Yep, you're catching up. Okay, so we can do all sorts of different things here. Okay, without going too much into detail, how do you do square root? How do you do square root? For example, I want to find the square root of 12. How do you do square root? What should I type? 12 what? Anyone still remember? How do you do square root? Okay, so let's go back to our regular maths again. Let's say I have square root of x. Can I actually convert this as x to the power of something? Square root of x is x to the power of what? Anyone still remember? Half, correct. So it's to the power of 0.5. Okay, so cube root, automatically it is x to the power of 1/3. Okay, so we can do a square root of 12 simply by the power of 0.5. Okay, now this is a more convenient way sometimes for us to do things. We don't have to use libraries or other mathematical operations. So some of these convenience method you have to roughly know. All right. So absolute simply means that, let's say if I take absolute of x, mathematically this is what you do. Absolute. Basically, negative become positive numbers, positive remain at positive numbers. Maximum, minimum, I think you know that quite well. So I can change my string to float and float to string. Okay, so any problem with this part here? It should be quite alright, not much confusion. Okay, this will be a big problem. Okay, can I count? So there are a lot of other methods, can I count and so on. So we are looking at A and B as a string, start and stop. So we'll look at some examples here. What this does is, in this string, okay, A, T, G, G, T, A, T, C, G, I want to count how many times A and T appears. So A and T appears where? One time, two times. Okay, so it gives me 2. Any problem so far? First example, okay. I need a sign. Okay, it should be quite okay. Okay, then what find does is, you go back to the documentation, it says find the first occurrence of B inside A. Okay, so find simply means that which position does the first AT happen? Can you find it? So it's from position number 0. Okay, so let's say we just collect this, for example. Okay, and I say find. For example, to find G. What will it give me? What do you think will be the answer? It's basically trying to give me the position whereby the first G occurs. 2, correct. Okay. Give me the position where first G occurs. Okay. So I can use it. I can, let's say, take this. And I want to find different things. For example, I want to find your TA. Okay. This tells me that is position number 4. So 0, 1, 2, 3, 4. So this is the position whereby TA occurs. So far, you can use this quite readily, right? So you can think about this is very simple. Let's say if I give you a gene sequence, I want to find where the first start codon. You can just use this method. Okay, you can really have a whole list of alphabet nucleotides. Then I try to find your first start codon, which is your ATG. Okay, that will find out. Or what happens if it doesn't comes into here? Okay, that's good question. So let's try. When you have question in this, let's try. So programming language, how can you find repeats? You can't find repeats. Okay. So for example, I want to find k. Gives me -1. -1 simply means that you just cannot get it. Because remember, Python starts with 0, so it cannot give you a 0. Ambrose, there's not much of being said here. What you can do is you repeat it. When we do loops, you actually see how it works. Okay. Because if you go back to the documentation, you can actually find this thing called start and end, which we never use. This part here, start and end. Okay. Okay, start and end. Let me just show you this example. Okay. Since I find my first G as position 2, okay, so what will I say this? I want to find 5. Ambrose, can you try to decipher what on earth this means in respect to my line number 53? Ambrose, are you there?
No, I don't know. Oh no, I accidentally click request control.
Okay. But do you understand what on earth this 5 means here? Okay, Rebecca, why not you try? You can speak out.
Is it repeat 5 times?
Is it to
No, it
find
doesn't.
for G after the position 5?
All right, it finds for G after position 5. So it's position 0, 1, 2, 3, 4. This is actually ignored. So it finds for G after position 5. So it actually found G on position 8. Otherwise, that means this 2G is technically ignored because it's only after position 5. It only finds for G in this 4 nucleotides. However, it still maintains the value. That means the position. So basically, Ambrose, what you can think of is how do you find repeats? So let's say I find the repeat of this 3. Okay. So originally I have this. Okay. Let's say 2. Okay. Now I decide, okay, can I find after 2? Okay. So after 2, I just take 2 plus 1, means after 2. You find position number 3. So now can I find after position number 3? Then you find position number 8. So this is where you can do your repeats if you want to. Okay, so simply, if we can reverse it, and we say that we want to find AT. Okay, so it gives me position 0. Okay, then I say that, can I find the next AT after position 0? So AT after position 0 means 0, oops, 0 plus 1. That means the next position. What I'm expecting is 0, 1, 2, 3, 4, 5. Correct? I'm expecting to find this position here. See, it gives me 5. Yes, you can save the next value and go on. Exactly. Yep, you can do that. You can do that. Okay, no problem. Okay. So another thing is we want to, let's say, do start with. Start with means you're actually asking Python, does the string that you have start with certain things? Okay, this may seem a bit oxymoronic in the first place. Okay, but it can be quite useful here. So can I say, does sequence starts with, let's say, ATG? Does this sequence actually starts with ATG? It doesn't, right? It starts with GGT. So it will give me false. Okay, so if I do the reverse, the sequence starts with G. Yes, it's true because it starts with G. So far, this can be quite useful for a lot of different things. Okay, when you process all your GIMBank files, FASTA files, you actually use a lot of this. Okay, since I can start with, I can also find ends with. Does sequence, this seq, does it ends with G? Obviously, does it ends with G? It's false. But does it ends with C? It's true. Does it ends with GC? It's true. Okay, then we can actually use all these for different purposes. Okay, replace is very commonly we want to replace one thing with the other. So it's actually imposition replacement. Okay, so let's say I print out my sequence first. Sequence. This is my sequence. I take sequence and then I replace a capital G with small g. So now all my capital G is replaced with small g. Can you see that? So far so good. I may not even just replace single alphabets. So let's go back to here. So can I replace all the G? Every time I see a GG, I replace with a HH. I can do that. I can even, every time I see a GG, I say it's a haha. Do that as well. So it doesn't just replace a single alphabet, it can replace a string quite readily. Okay, anybody actually ever mentioned to you by convention we tend to write nucleotides this way? That means small g. Did anybody tell you that before? No. Okay. It's a good practice when you want to write things on paper. When write your nucleotides, your guanine as a small g. The reason is this: when let's say you order primers, you have to write sometimes. Even in computer print, you have print out, so you can write C, let's say C, C, G, C, A, T, T, A, G, and so on. Now you realize that if your handwriting is as miserable as mine, your C and G can look pretty much the same. So you actually write this so that you will never get it wrong. The last thing you want is your C and G is mistaken for something else. Okay, so this is a thing that I learned during my own poly days. All right, so upper and lower, simply you take the string, convert it to upper or lower case. Okay, that's all, nothing very much. Assignment, we actually have done assignment all the time. For example, when we say that your sequence equals a sequence, that's called assignment. Oops, I forgot. It's called assignment. You assign something to something. Okay. If you still, how many of you still remember using R in your PDA? R has two forms of assignments. One assignment is equal, another assignment is this. Okay. So Python only have one assignment. Python cannot use this. Okay. So in R, you can actually write this x 5, but Python will not recognize this. In a sense, if you use R, you can actually write this. So x 5. Python will give you an error, but R will not give you an error. Okay, now, so what you do is once you assign, you can actually call the value itself. So every time here I call sequence, it gives me my sequence. Basically, I call x. X equals to 5. When I call x, it means asking for 5. But let's say if I mistake and I have a capital S, this will give me not defined because this doesn't work. Or I say sequence, so not defined. This means that Python is very sensitive to first spelling errors and case sensitivity. You always have spelling errors. Please check your spelling errors. So far, so good. Okay, here is just give you this list of augmentation. Personally, I will prefer you not to use this augmented assignment. That means a shortcut assignment. Use the full mathematical form. Don't use this because over time, unless you're used to it, it will give you error. So what A plus equals B simply means A plus B and store it in A. Okay, B minus equals B means A minus equals B means A minus B and store it in A. Okay, so this can be a bit confusing. Sometimes you will treat it as A plus B and store it in B instead. So please do not do that. Okay, always use the original assignment. If you are using other, you can see this acceptable. This is logical, provided you can remember how to do it. All right, so far any problem? Okay, so what I want you to do now, basically I'm going to end the class now. What I want you to do is spend the rest of the 30 minutes or so, do your tutorial, and we'll go through a tutorial tomorrow. Okay, the tutorial is actually not very difficult. So your tutorials, I believe I've already put it up already. So your tutorial, okay. Very often what you do in your tutorial, let me just show you. Yep, you just practice. You type this in and see what happens. Type this in and see what happens and so on. Okay, type, don't copy and paste. Copy and paste, you will not learn anything. Learn how to type. So far, okay? Any problem? Wait, so the Python code, so what does it mean? Like Python is able to remember a lot of answers, and if I constantly saw the answer is 8. Yes, yes, yes. Actually, I don't really quite understand what you're trying to say, Rebecca. Assuming I store a lot of answers if I constantly. Okay, so okay, see, you can say A equals to 4. Then I can say A equals to A plus 3. So now A becomes 7. It doesn't store many, it stores the last one. A equals A plus 2. So now 7 becomes 9. Make sense? It starts from 4, becomes 7, becomes 9. Okay, this is what you're trying to say, right? It doesn't store multiple copies of A. It stores the latest one. Yeah, it's actually this max. Yes, yes. It stores the latest value. All right, any problems so far? Are you ready to go? Okay, so